So in this short video clip, I'll be explaining how we use a quadrat to measure the abundance of any given species through a number of techniques which will allow you to evaluate their suitability for different investigations. So what we see here is obviously an artificial species. It's actually known as Sutton's Sorter squarus. It was created by Robin Sutton, and Sorter squarus regulatus is not a real species. It's a jigsaw puzzle that tessellates together. So we use this as an exercise to consider how we're measuring abundance, and essentially the abundance of an organism can be measured in many different ways. We're asking the question, how much or how many species of the species are present, some idea of the amount. So first of all, we're using a quadrat. This quadrat here is known as an open frame quadrat. There is no grid in it. It is open, and it's a 50 by 50 centimeter open frame quadrat. Now, the first method we can use is often the most obvious method, is to count the number of individuals in the quadrat. So if you'd like to count the number of individuals there, you can pause the video at this point to count them. And then we should be getting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 individuals inside this quadrat. Now, this is called the density of the organism. And what we've just counted, 21, is the density in 50 by 50 centimeters. And so this would be 4 times as great in a meter squared. And so we can end up with a density of 84 organisms per meter squared. It's a population density of the organisms we see. It's not always a suitable method. It works when the organisms are similar in size. It's quite a quick method. It's a good method for measuring abundance of often animals, and particularly animals that don't move, what we call sessile organisms like barnacles or limpets or shells, and we get a quick count of density. It can also be useful for things like flowers rather than whole plants, because plants are often not clearly recognizable as individuals, but the number of flowers can be. Or plants that are clearly individuals and similar in size. Things like grasses that are connected by underground roots. These are not particularly good. If you pull them up, they might all be connected. That's population density. Density is one of the measures of abundance. The second measure of abundance I'd like you to have a go at is called the estimate of percentage cover. Now, in this estimate of percentage cover, you are literally going to estimate what you think the 2-dimensional percentage cover is of the organisms in this quadrat. Now, to do this, there's a number of little techniques that field ecologists use. One is recognize that you could divide it into quarters. And if you divide it into quarters, then how much of the space here would be occupied, or you can use your hand. A balled fist like this is roughly 5% of a 50 by 50 centimeter quadrat. Estimates of percentage cover vary greatly between individuals. They are what we call a very subjective measure. We can be more consistent with them over time, particularly if we practice it, and so we look back and see, do we get a similar estimate of percentage cover? And they're quick. One of the reasons why students like to use them in projects is they're very quick, and they can be useful for a student doing it the same way each time to actually get a good measure of percentage cover. So if you would like to make an estimate of the percentage cover in this quadrat, you might want to pause the video right now to do so, write it down, and then we can move on to another commonly used measure of abundance. The next measure we're going to look at is called the frequency. And the percentage frequency of a species is how many times it occurs within the total number of samples. So in this case, with frequency, the frequency of this species in this quadrat is 100%. There's only one quadrat there, and it's in it. It's obviously not a particularly useful measure in that case. So what if we increase the number of squares that we are actually going to be recording it in? Now we're using not the 50 by 50 centimeter quadrat, we're now using what is known as a gridded quadrat. And in the gridded quadrat, we can now see that the species is present or absent in a number of the squares. So this is an objective system because it's pretty binary. It's either present or absent. So no, yes. So 1, 2, 3, 4. Now, if you'd like to pause the video, you can have a go at collecting the percentage frequency out of these 100 squares. And if we collect them, we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76% frequency in 100 smaller squares. So this is a measure here then of smaller quadrats that are 5 by 5 centimeters. So there's 100 smaller quadrats within the 50 by 50 gridded quadrat. Now this technique of percentage frequency is more objective, but it doesn't necessarily mean that it's a better measure of abundance. What did that figure mean? Well, we can be certain it's linked to the amount of the species in the quadrat. We can't be sure it's linked to the percentage cover. It's why we call it percentage frequency. Actually, field ecologists have developed the technique of percentage frequency to the point where it's recognized that the percentage frequency is best collected by many smaller points. It's perhaps worth recapping on what we're using a quadrat for here. A quadrat is a standardized unit of sampling. So it's the same unit of sampling wherever you go. It allows you to extrapolate data to make predictions about total numbers of organisms in a larger area. And it allows you to easily compare the abundance in different habitats. Obviously, if that measure is not objective, it's not a very good comparison. So the standardized measure can be reduced to a smaller area still. It's called a point. And if you use an object for pointing, like here I'm using a spatula, and I can now count whether or not the point touches the species at all the intersections in this quadrat, and I got 0. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 27 points. And in this case, we could work out the percentage of the total number of points. So this would be equivalent to 27 divided by 121. And this would actually give us a more accurate measure. 27 divided by 121 as a frequency is 120 points. And this gives us 22% cover in this quadrat. So what these different measures of abundances allows us to consider then are actually something you can't do in the real world, and that is you can bring the pieces back and see exactly how large the quadrat is. So which one was closest to the real number? Well, so now we see that the species has been gathered together in a way that you can't do with actual species in the field easily. And we can see it occupies a quarter of the area of a 50 by 50 centimeter quadrat. The jigsaw puzzle is 25 by 25 centimeters. So we can see it is precisely 25 centimeters by 25 centimeters, quarter of the quadrat area that we've got here. So which was our closest measure? Well, perhaps your estimate of percentage frequency was close. Actually, with students, there is a lot of variation in what they estimate. It can be 10% lower, it can be 20, 30% higher. It does help with a little training to improve the student performance on that, or anyone's performance. Obviously, with the percentage density measure, the closest one that we had was the percentage frequency from 121 points, which was closest as an objective measure. So ecologists use point quadrats to do this in the field, which are apparatus that normally has a rack with 10 points that you can drop needles into grassland. It's normally used for grassland and low-lying vegetational communities. It's obviously not suitable for looking at trees in a wood. But point quadrats use this principle for estimation of abundance. One other point to add into this video is really that we can also improve our performance with percentage cover data by using what are called abundance scales. Now, the abundance scales means that you can record with a suitable scale, such as AC4 or DOMIN. We can use categories. So AC4 is abundant, common, occasional, frequent, or rare. And the categories are used for species in that community in order to avoid the subjectivity of some of the percentage measures. They tend to emphasize very small percentages in different ways, like the numbers of plants, more specifically. And one thing that you can do with AC4 scales is you can actually compare them for different habitats. So with an AC4 scale, you can compare count data, for example, on the rocky shore of barnacles with percentage cover data for seaweeds, meaning it's quite useful to do whole community studies using such scales.